In this video, we will learn about the Charles law. So like most solids and liquids do, gases also increase in volume when they are heated. But for the gases, the relative effect is much more pronounced. So studies regarding the effect of temperature on the volume of gas at constant pressure were first carried out by Jacques Charles in 1787 and then extended by Joseph Gay-Lussac in 1802. So the generalization that was obtained from those studies is known as Charles' law, which states that the volume of a fixed mass of a gas increases or decreases by 1 by 273 of its volume at 0 degrees Celsius for each degree rise or fall in temperature, provided pressure remains constant. Let's say the volume of a fixed mass of a gas at 0 degrees Celsius is V naught and at T degrees Celsius it's Vt. Then according to the Charles law, for every 1 degree rise in temperature, the volume will increase by 1 by 273rd of its volume at 0 degrees Celsius. Means if I have to write the value of Vt, so it will be initial volume plus I have increased the temperature to T degrees. So the volume will be V naught by 273 times T. From here we will take V naught constant. So it will be Vt equals V naught into 1 plus T by 273. Now let's see the graphical representation of Charles' law. So when we plot the volume of a fixed mass of a gas against the temperature, we get a straight line. So from here we know that volume of a fixed mass of a gas varies linearly with temperature at constant pressure, means they are directly proportional. If temperature is lowered sufficiently, gas liquefies and no more experimental points can be obtained. But if like at this temperature the gas will be liquefying, but if we extrapolate to lower temperature, we can see it reaches at the point of zero volume, and the temperature at which the volume of the gas becomes zero is minus 273.15 degree Celsius. So this temperature, now below this temperature, we can say decrease in temperature below minus 273 degrees Celsius would be impossible, because it would correspond to negative volume, and we know that negative volume is meaningless. So the lowest possible hypothetical or theoretical temperature which can be attained is minus 273 degree Celsius, at which all the gases are supposed to have zero volume. So this temperature is called absolute zero, and as stated earlier, Lord Kelvin suggested a new scale of temperature which is starting at minus 273 degrees Celsius. That will be the zero of the Kelvin scale, so it is equal to 0 Kelvin. So this scale of temperature is called Kelvin scale or absolute scale of temperature. So now let's see another way of stating Charles' law. So we know Vt is equal to V naught 1 plus T by 273. So from here, if we put 273 plus T as T, which is the temperature on Kelvin scale, because we know that if we want to convert degree Celsius to Kelvin, so we have to add 273. So 273 plus T will be capital T, which is in Kelvin. So from here we can say Vt is V naught into T by 273. Now here the volume of the given mass of the gas at constant pressure are V1 and V2 at two different temperatures T1 and T2. So from here we can say V1 is V naught into T1 by 273, V2 is V naught into T2 by 273. So from here we can say that volume is directly proportional to temperature. So the alternative statement of Charles' law is that the volume of a given mass of gas is directly proportional to its temperature on Kelvin scale, provided the pressure remains constant. So I hope it is clear to you. Thank you.